Welcome to the forecast module on surface features, approximately 7:30. And what I hope to accomplish with this particular module is that on January we will be doing a laboratory, and one of the labs that we'll be doing is on surface fronts. And in fact, if you think about surface, it's the area of the Earth that we walk around on. And in fact, we will talk about such surface features as fronts, low pressure systems, high pressure systems, and we'll learn how they move, because typically weather is associated with fronts. You've heard terms such as cold fronts, warm fronts, stationary fronts. The cold front is simply meaning that as a front moves through your area, temperatures will drop. It will get cold. And to look at surface features, I click on this particular link here, and it will bring up a site that you're probably pretty familiar with, the Weather Channel. The only thing bad about the Weather Channel link is that a lot of pop-ups start occurring, but that's okay. Well, it's with most websites there are pop-ups. But what you're looking at here is what we call a surface map. And on this surface map, we look for features such as low pressure centers, and winds around low pressure is counterclockwise. We call this cyclonic flow. The H here that you see is what we call high pressure, and wind flow around high pressure is clockwise. Typically, you tend to see clear skies, light winds associated with high pressure. So fair weather around high pressure, and around low pressure, we typically have inclement weather. And you see right here, in fact, over Kansas, portions of southeast Nebraska, half the state of Kansas, there is area of snow. And it's not unusual to see precipitation associated with low pressure. And we certainly see that feature here. If we look down to the southeast along the Gulf Coast states, you'll see a low pressure system, and you'll see rain, and even some embedded thunderstorms in Georgia, South Carolina, and a little bit of freezing precipitation as we move up into northern Georgia, some snow, and then again more rain as we head up into Kentucky, and then as we head into Indiana and southern Ohio, some freezing rain. So there are two major areas of weather occurring on Wednesday evening in the southeast U.S. associated with this low pressure center, and then in the central states associated with this low pressure center. Also notice this blue line here. You're probably aware of this. This is called a cold front. And typically cold fronts will move from west to east across the U.S. They may move directly eastward. They may move to the northeast. They may move to the southeast. But there's some west to east movement of cold fronts. Down here, right along the northern Gulf Coast, you see this red semicircles with a line, and that is an indication of a warm front. Warm fronts tend to move to the north. They also move to the north, to the east, northeast, and typically as they move over an area, temperatures begin to warm. Now we'll talk about cold fronts and warm fronts in more detail later on in the semester. But as you're looking at this, you should notice that all the active weather is occurring near fronts and low pressure systems, as we see right here. Around high pressure, over here in the northeast, and high pressure back here in the northwest, you don't really see any precipitation. So that's typically associated with fair weather. Now, what we need to do, and what we have done by the time you're viewing this module, you will have been able to figure out, or you will have learned, how to move fronts.
500 millibar map, we'll talk a little bit later. Actually, what we're going to use the 500 millibar map, we're going to use this map along with the surface map. And in fact, if I just show you this, we're going to use the surface map with the 500 millibar map to move surface features. So we see that we've got a low pressure. Let's just take this low pressure here that's sitting up over south central North Dakota and north central South Dakota. And let's take that low and let's draw it on our 500 millibar map. Okay, I'm just taking the surface low and moving it down here. And let's draw the front along with it. There's another low pressure here. And see if I can get pretty close to this. And then we've got a warm front up here. So let me just draw in the warm front. Okay, so I've tried to do a decent job here of, this is the warm front, cold front. I should have drawn it in blue, but I'm not exactly sure how to change the color on this right now. But if I want to know the direction this surface low pressure is moving, okay, I want to find out if it's low pressure, because one of the things you have to forecast for are fronts. So you got to figure out, is this front going to get close to Iowa? Well, surface features such as low pressures and fronts follow parallel to 500 millibar isohyps, these contour lines, these blue lines. They act kind of like highways. So in other words, the low is not going to cut across the isohyps, it's going to go parallel to it. So the direction that the surface low would follow would be parallel. See if I can ignore that marking there. Going to have to use the pencil. And so the low is going to track parallel to these isohyps at 500. So will the front. So the front, this cold front and low, is going to move off to the northeast. Doesn't look like it's going to get any closer to Iowa, because the front and the low pressure centers are parallel to the isohyps pattern. It will continue to move off to the northeast. Now, you can pick up the direction of these surface features. So you can pick up the direction of the surface features. This low and front should continue to move off in this direction, dragging the front along with it, and really not getting any closer to Iowa because of the isohyps pattern here at 500 millibars. Now we can figure out how fast this low and the fronts are going to move. So let me clean this up a little bit. You're going to have to do a lab with this on moving fronts. So that's why I'm showing you this. What we'll do, and I'm going to leave the low there, and so let's track this low. What you want to do is that typically surface features such as low pressure centers, recall winds are counterclockwise around low pressure centers, the low is going to move, the surface low is going to move roughly at about half the speed of the winds at 500 millibars, where that surface low is located. So the winds over South Dakota and North Dakota looks like they're at about 20 knots. So the surface low itself is going to move at half the speed of the 500 millibar winds, and so that surface low is going to move roughly 10 knots, or 10 nautical miles per hour is how we'll say it. So this surface low will move 10 miles per hour to the northeast. dragging its front along. So if I'm looking at this, and this surface map is 4:23 Central Daylight Time, so we're at 4:30. If I want to see how far it's going to move in 24 hours, 4:30 tomorrow, May 19th, I would take the speed of the low, 10 miles per hour, and multiply it by 24 hours. That's hours right there. And so it would move 240 miles to the northeast. In other words, that low's not moving very quickly. If you look at Iowa, you can use Iowa as a good way to, roughly from west to east across Iowa is 300 miles. So if I were to take this and move it up here, I don't want to resize it. 300 miles is roughly right about, or 240 miles is about right here. So the surface low would move to about right here by tomorrow afternoon. So the new location of the surface low, along with the front, would be about right here. So it gets a little bit closer to Iowa. You see right here, it's over northwest Nebraska, and actually it's still in northwest Nebraska. So it's not moving close. It's not moving very closely to Iowa. It will continue to move off to the northeast. So now you know how to move, and we can do the same thing with high pressure too. We can figure out how quickly high pressure will move in the direction. So let's take that high that's sitting off the boot of Louisiana. The wind speed around that, the nearest wind speed we have is up in Mississippi. That may be Jackson, Mississippi. Looks like a 5-knot wind, 10-knot wind here. So roughly, if you average the two wind speeds, you're looking at about 8 miles per hour. So 8 miles per hour in 24 hours would be, let's see, well, it would be less than 240. So let's just say about 200 miles. And you notice the wind direction's out of the northeast, so it would drift slowly parallel to the southeast, parallel to this isohyps here, off to the southeast. Not moving very far at all. So why do you care the location of highs and lows? Because it shows you where the wind direction. So if the highs just moved off to in the Gulf just a little bit tomorrow, we're still going to get winds, surface winds out of the southeast. And around the low, we get counterclockwise winds. So for tomorrow, our winds should continue to stay out of the south-southwest. And if these isobars, if they're moving in the same direction as the front, our wind speed will be about the same, right around 15 knots. So I'll give you a lab where you can practice moving fronts. And it's a good idea to be able to move fronts because we know that precipitation occurs around low pressure, around fronts, and fair weather around high pressure.